Challenger, January 28, 1986, Cape Canaveral, Florida. A cold morning and a launch that was supposed to feel routine became a tragedy broadcast live. The space shuttle had become a symbol of trust. NASA had flown many missions before. This flight even carried a school teacher to send a clear message. Space was becoming something ordinary people could be part of. Thousands watched in person, millions watched on TV. Most people felt confident, but the cold made a small detail deadly. A seal in the solid rocket booster joint did not work as it should in low temperatures. Seconds after ignition, hot gases escaped through a gap that should have stayed sealed. The failure escalated fast, going from manageable to irreversible in moments. It happened in front of everyone. The crowd went quiet. At first, some people thought it was a normal technical problem, until they realized it wasn't. 7 crew members died. The footage played again and again, not for drama, but for shock. The public was left with one question: how could a system this advanced fail because of one small part and one decision? The investigation showed it wasn't only a hardware problem, it was also a decision-making problem. NASA grounded the shuttle fleet, redesigned the booster joints, and changed how safety warnings moved from engineers to managers. Challenger became a lasting lesson. When systems grow larger, risk can start to feel normal until the day it no longer is. Bhopal night of December 23, 1984, Bhopal, India. A city was asleep, and an invisible gas entered homes in silence. There was a chemical factory with tanks holding dangerous materials. On paper, safety procedures existed. People had lived near the plant for years, like in many industrial cities. Many residents did not know exactly what was stored behind those walls. They only knew the factory meant jobs. That night, a mix of failures and negligence created a simple path to disaster. A highly toxic chemical escaped containment. The problem was not just a leak. With a substance like this, minutes matter. The gas spread through the air, sank low, and settled into streets and alleys. It quickly became something people could not see and could not understand. The result was a mass human tragedy. Thousands died, and many more were harmed. The city fell into panic. People ran, shouted, and tried to reach their families. Hospitals were overwhelmed within hours. The media recorded it as one of the worst industrial disasters in history. Bhopal became a global warning. If industry grows without strict safety standards, it can change an entire city in a single night. Bhopal ignited worldwide debates about process safety, government oversight, corporate responsibility, and the public's right to know the risks near their homes. Lawsuits, public pressure, and reforms around hazardous chemical management intensified after that night. Bhopal became a lasting symbol of one lesson: safety is not a choice, it is a requirement. Deepwater Horizon, April 20, 2010, Gulf of Mexico. In the middle of the ocean, under bright floodlights, a failure rose from deep underground. Modern drilling rigs were built on trust, multiple safety layers, expert crews, and one common belief: if something goes wrong, backup systems will stop it before it becomes a disaster. At the center of that trust was one critical device, meant to be the final break, the last line of defense. But in high-pressure drilling, failures often come as a chain. Warning signs can appear and still be ignored. When control of the well was lost, events moved faster than people could decide what to do. Explosions followed. Fire spread across the surface of the water. On a rig, escape routes are limited, and every second matters. 11 workers died. The rig was eventually destroyed, and the crisis became a major environmental disaster. Images of flames, smoke, and containment efforts filled the news for days and weeks. The public demanded answers. What failed: technology, management, oversight, or all of them together? Investigations and court cases led to major reforms: tougher regulations, stricter well-designed standards, stronger safety testing, increased government oversight, and changes to decision-making culture in the oil industry. Deepwater Horizon became a reminder that when the last line of defense fails, an industrial project can turn from a business operation into a national and global crisis. May 6, 1937, Lakehurst, New Jersey. A silver airship descends toward its mooring mast, and the future of travel is about to vanish in minutes. The Hindenburg was the pride of airship engineering, an enormous passenger craft designed to cross the Atlantic in comfort. To the public, it looked stable and controlled, like a floating hotel. People trusted it because it moved slowly, landed gracefully, and represented modern progress. The hidden risk wasn't the size of the ship, it was what lifted it. The Hindenburg used hydrogen, a highly flammable gas. During landing, a leak and ignition event occurred. The exact trigger has been debated for decades, but the fundamental flaw was that the system depended on a gas that offered almost no forgiveness when something went wrong. Dozens died. The disaster was captured on film and broadcast widely, and that footage did something no technical report could. It ended public confidence. Overnight, passenger airships shifted from next era of travel to never again. Airship travel for passengers collapsed. The event accelerated the world's pivot toward fixed-wing aircraft and reinforced a principle engineers still repeat. If your core material choice is unsafe, elegance and innovation cannot compensate. November 7, 1940, Tacoma, Washington. A brand new bridge moves in the wind at first like a gentle wave, then like something alive. The Tacoma Narrows Bridge was designed to be modern and efficient, slender, lightweight, and beautiful. The public trusted it because bridges are supposed to be permanent. Steel and cables feel like certainty. The failure wasn't simply strong wind, it was aerodynamic instability flutter. The wind didn't just push the bridge, it interacted with the bridge's shape and flexibility, feeding energy into the structure. The oscillations grew until the bridge could no longer sustain the twisting motion. The collapse was filmed, becoming one of the most famous engineering videos ever recorded. Remarkably, there were no mass casualties, yet the psychological impact was enormous. People realized a structure could look solid and still be fundamentally unstable. Bridge design changed permanently. Aerodynamics and vibration stopped being secondary concerns and became core requirements. Wind tunnel testing, structural damping strategies, and deeper dynamic analysis became standard for long-span bridges.